So we are back again in the chapter 2 of the differential equation, which is the solution of some first order first degree. So we have several topics for this chapter: the variable separable, the homogeneous, exact, linear, equation linear, unique function, and the Bernoullis. But for today, I am going to discuss the homogeneous. So for homogeneous, we have the definition that if the function of mxy and function of nxy are homogeneous of the same degree, then the differential equation is homogeneous. So we have this form wherein any function with dx should be named as function mxy and any function with dy should be named as nxy. So to test if the differential equation is homogeneous or not, we can replace the variable x and y in the function mxy and nxy by the tx and ty. So that gives us this form of the function mxy into mtxty and should be simplified into this form. So we take out t from the function. So for function ntxty, the same goes. So we need to replace the nxy to txty and then factor out the tn. So the m and n are the power of the variable t, which is the most important part in replacing the function m and n with with tx and ty, because if m and n is equal, then the differential equation is homogeneous. Now, there are several steps in solving homogeneous differential equation. So the first is substitute natin si x by vy or y with vx. So you just need to choose one, and then the purpose of such manipulation is para po matransform natin si differential equation into variable separable. So pag matransform na po natin siya sa variable separable, we need to follow the steps for variable separable. And that is first is to group the y with dy and v with dv, or x with dx and v with dv again. So let us now integrate the differential equation after grouping the y with dy and v with dv. And then we need to return the original variable x and y. Hence, the result in this solution is the solution of the differential equation. So, for example, it is seen on your screen. So, I do not need to read the example. So, that is the given. And now we need to verify or check if the differential equation is homogeneous. So, to check, so this function here is called the mxy, and we need to turn it into mtxty, and that gives us so it gives us that the function 3 times 3x squared plus y squared is now 3 times the quantity of 3tx raised to 2 plus ty raised to 2. And simplifying it, we now have 3 times the quantity of 3t squared x squared plus t squared y squared, and that gives us 3t raised to 2 times the quantity of 3x squared plus y squared. And that gives us an m equal to 2. Now we have 2x, which is the function nxy of your equation, and we need to turn it into the function ntxty, and 2xy becomes 2tx times ty, and that gives us 2t squared xy, and that gives us an n equal to 2. Then, as you observe, your m is equal to 2, so we can say that the differential equation given is a homogeneous. So now we can apply substitution in the differential equation, which is the first part of or first step of the homogeneous differential equation. So we need to choose whether to substitute x is equal to vy or y is equal to vx. So in my case, I chose y is equal to vx, and deriving it, we have dy is equal to v dx plus x dv. And then substituting the new y and dy to this equation, we will have this second equation. And then simplifying it, we have the third equation, and the next, the fourth equation. And observing that fourth equation, we know that these two terms can be combined since they have both v squared x squared dx in their variables. And adding them or subtracting them will give you 9x squared dx plus v squared x squared dx minus 2vx cubed dv is equal to 0. Now, can we still simplify this? No. We can now proceed to the next step since this is the simplest form we can get from the equation by substituting. So now we can proceed to the next step, which is grouping the y with dy and v with dv, or x with dx and v with dv. But in this case, we have x dx and v dv, so we need to group x with dx and v with dv. And then it gives us this equation wherein I tried to put all dx in the left side and all dv in the right side to make it easier in my case. So it depends on you on how you want it to solve, but take my you can take this step in order to make it more easier for you. So by separating dx and dv, this gives us this equation, and after that we can still simplify this equation since we have common terms in the left side. We have x squared and dx. So we can rearrange it or simplify it, and that gives us x squared times the quantity of 9 plus v squared dx equal to vx cubed dv. And now, can we now separate x with dx and v with dv? Yes. And I did it by dividing both sides by 9 plus vx squared times x cubed. And now we can divide 9 plus v squared in the left side and also the x squared x cubed. But we still have x in the denominator. And then at the right side, we can eliminate the x raised to 3. And that gives us dx over x equal to 2v dv over 9 plus v squared. Now, can we still simplify this equation? No, this is the most simplified for this step. So we can now integrate. So integrating the differential equation, observing the differential equation, you can see that we can directly integrate the equation, and that gives us ln x equal to ln of 9 plus v squared plus c. So we have now the c since this is integration, and we have to add the arbitrary constant. So arranging the equation, we will have this ln x minus ln 9 plus v squared is equal to c. And by properties of logarithm, we can change the equation into this form because of the properties of logarithm. That is why I want you to review and recall and study the properties of logarithm, because that is very important in the differential equation. So now, after using the properties of logarithm, we can still simplify more the equation by letting c be ln c, and that gives us this fifth equation. And then, now, we can use the property of logarithm to eliminate the ln. So remember that we have e raised to ln x is equal to x, and applying this property, we have this equation. And now we can simply eliminate ln from the equation by this property, and that gives us this equation wherein x divided by 9 plus v squared is equal to c. And still simplifying the equation, we can have x equal to c times the quantity of 9 plus v squared. And this is now the time to return the original variables to get the final answer. So we let y is equal to vx, and therefore v is equal to y over x. And then this is the equation, substituting v is equal to y over x. That gives us this second equation. And multiplying both sides by x squared, we do have now x cubed is equal to c times the quantity of 9x squared plus y squared. Can we still simplify this equation? No, this is the most simplified form of the equation, and we cannot simplify it even more. So, this is the general solution for this problem. And for more examples, read more and solve more in the reference book. And this is my reference books, J. Pirante, W. Pirante, F. Gumba 2014, Differential Equation 2nd edition work textbook. And we also have the E. Rainville P.B. John 1989 Elementary Differential Equation 7th edition. So this is the end of my topic which is about homogeneous. I hope you learned something and I hope you enjoyed listening. Thank you.